4B extension. You will find this in the last pages of your packet, including the additional page that I did not include, so you'll have 2 pages. We're working with compound inequalities. It is a little tougher topic, but we'll get through this. So I have a compound inequality. I have multiple solutions, but they're separated. So I have x is greater than 2 and x is less than or equal to 5. You will see it most commonly in this manner. So you want to think of it as my answers are between 2 and 5. So here is 2, 3, 4, 5, 6, and 1. And it's open circle, and 5 is closed circle. So the answers are in between. So I'm going to shade that. So I think of them as between 2 and 5. Then I have the or situation. So here I have -1 and 2. So let's do -1, 0, 1, 2, 3, and -2. At -1, it's an open circle, and I know I could choose answers to the left of that. And just a reminder that if the x is on the left, I could just think of it as my arrow. It's going, they match, if it's on the left. Here it's also on the left, and it's 2, and it includes 2, so that's a closed circle, and it's anything to the right of that 2. So ors are usually done the same way. They look like this, and the ands are in between. So now I have a graph, and I want to see the notation for that. So I know it's between, I'm going to say it's going to be x is less than -1 or x is greater and equal to 1. Now, and then my interval notation, we talked about that, and I know, so it's going to be 2 pieces. I could go from negative infinity to -1, but not include 1. In union with, I could include 1, so that's the closed bracket, and to infinity, but I could never reach. And the way I remembered, like that looks like an equal sign. So here, my next graph is anything between 0 and 3. So I know I'm going to do, so x is in between, and it's between 0 and 3. So that's going to be a closed circle, and this one will be open circle. And again, in interval notation, it's between 0 and 3. I could equal 0, but I could not get equal 3, so it's close to 3. Okay, now how do I solve equations with a compound inequality? So it's the same as solving equations, but now you have 2 to solve. So when I use colored pencil, please use yours. So I think of this as 2 problems to solve. So I'm going to make sure I line up that inequality, and I'm using these lines to remind myself I have 2 places to do this. Okay, so I'm going to circle my variable. I'll circle the variable. Now I need to get rid of that +1. So I'm going to subtract 1 from both sides. So I'm subtracting 1 here and here. So I have to do both. So that's why I did the dotted line. And I'm left with, I'm going to bring down that equals, what happened? That inequality. And I get a -6. And then this goes away and I have my x. And this gives me, bring down my inequality, and that gives me 1. So I could go anywhere between -6 and 0. So here's -6, 1 and 1. So I'm going to put 1 here, and that's also open circle, and then I'm going to graph those, okay? And then my interval notation, anything between -6 and 1, and I can't reach those, so that's how I'd write it, okay? Again, here I have another one, and I'm going to draw my lines just to remind myself I really do have 2 equations to work with. Okay, so I'm going to identify my variable, and I'm going to add 1 to both sides, and I'm left with a 3x. Bring down my inequality, and on this side I have a 12, and on the other side I have a 9. Bring down that inequality. Now I have to divide by 3 by both sides, or all 3 sides, I guess, and bring down that inequality. Since I didn't divide by a negative, I don't flip this. I have 4 here, I have x here, and I have 3 here. So I could do anything between 3 and 4, close circle at 4, open circle at 3. Again, the ands will always look this way. And my interval notation, anything between 3 and 4, close to 3, it could equal 4. Okay. I'm going to skip this one, but actually, no, I'm fine. Again, I'm going to remind myself there's 2, it's a compound inequality. Oh gosh, touch screens. And I'm going to add 10 to both sides. And this gives me an x, bring down my inequality, and I have 5 on this side, and I have 1 on this side, and bring down that inequality. So now I have my answers between 1 and 5. So I'm going to put 1, 2, 3, 4, 5. These do fit. I could get close to 1, but not equal 1, close to 5, but not equal 5, and it's anything in between. Okay? And I know it's there, so let's test 3. If I test a 3, is that a true statement? Yes, it does. So I kind of do a mental check. Does it work? And my interval notation is 1 to 5. Could not touch it. That's so easy this way. But for us, because we're introducing this notation, it's because you'll see it. And it is kind of a required thing to know in high school. They use that a lot. Okay, so here we have this one. Again, I have a compound inequality. I'm going to make sure I didn't make any negative answers. Darn. Okay, so I'm going to focus on subtracting this 5 across both inequalities. And I have 3x, bring down that inequality, and I have 6. Bring down that inequality, and I have 9. And I'm going to divide by 3. You know what? Let's make this one a negative so that you're used to flipping those signs. I'm going to divide by a negative 3. Well, actually, that won't work. Okay, ignore that. Okay, I'm going to divide by 3 on both sides, or across both of those. And this is my division symbol. I do not want to see this. This is so elementary. We do not want to see that. And then I have 9 divided by 3 is 3. This goes away and I have an x. This goes away and I have a through 2. And so I know I could go anywhere between 3 and 2. Now notice I have, let's see, is that a solution? I don't think it's a solution. Let's look. So I have to put my number less. So I have 2 here and 3 there. So I know I'm going to rewrite this so it's in the proper order. So I have x, and I have to put 2, well, I'm running out of room. So I'm going to put it on the side over here. So I have, let's see, trying to see how I could squeeze it in here. So I have 2. Notice that this is facing here, and my 3, this here is facing the x. So that's how I see it. See how it's eating the x? I still want to make sure. So now I have, so this x is 2 is greater than x. Well, that's over in this direction. And x is greater than or equal to 3. And that's over here. But because it says and, this says and, these here, this is like negative 4 is greater than, this is my and. This is a no solution. Okay, that's a no solution. Because it has to be in the center. So it did not include those, so this is a no solution. Okay. I'm just confirming that. X is, yeah. Now let's go over here. Solving inequalities with an OR. So with an OR again, I'm going to solve them one at a time. Okay. So again, here's my OR. I have this or that, and I know it's going to be my split inequality, like this one up here, like this one there. Oh, sorry, my ORs are the split inequalities. ORs always are split and are always in the center, always. Because in our last example it was not, there is no solution. It doesn't work because it doesn't meet both criteria. For example, if I pick 5 here, if I place 5 here, that is not a solution for this side here. That's why it's a no solution. So let's look at here. So I have an OR. I know it's going to be graphed on either end. So I'm going to solve my first one. I'm going to subtract 2 from both sides, and I get x is less than 10. And over here, I got to do this one. I'm going to subtract 5 from both sides, and I get x is greater than or equal to 14. So now I'm going to graph it. So I have 10. I'm going to put 10 here, 11, 12, 13, 14. And I have open circle at 10, closed circle at 14. And this one here goes that direction, and this one will go this direction. This one's really easy because x is on the left, so I know I'm just going to follow that arrow direction. X is on the left, and see how they match. That's a real quick way to kind of think of it for graphing. Let's do the next one. Again, it's an OR, so when I graph it, it'll be split. So I'm going to circle my variable, bring down my inequality. I'm going to add 5 to both sides, and I get 4n equals 16. Divide by 4. Again, we do not use that symbol. And I get n is greater than 4. Or I have this here. I'm going to bring down that inequality. I'm going to subtract 9. Subtract 9 from both sides. And I have left a negative 8n, gives me a 16. And I'm going to divide by a negative 8. And I get n is greater than or equal to, because I divided by a negative, I'm going to flip my sign, and I get negative 2. Now I'm going to graph each one. So I'm going to put this on the left side. So I have a negative 2, and I'm going to put 4 over here. If you don't write your numbers in between, I'm totally fine with that. At 4, it's an open circle, and at negative 2, it's closed circle. Now, so with my negative 2, the variable's on the left, so I could just say, oh, it's going to the left. That's a quick way of looking at it. My variable's on the left, and it goes this direction. See how this matches that? That's a quick way. It has to be on the left. Okay, so my ORs always look that way. Okay, and all right.